We guys already discussed in the past few shots that which is the fun reaction for which about half the people alive today are in existence. Right now, the air around you is almost 80% nitrogen, but the plants again, I'm telling, can't use it. The nitrogen gas is an incredible stable state. Its atoms are locked together so tightly that most biology can't break them apart. For most of the human history, this limited how much food we could grow. But this changes in the early 90s when Haber-Bosch process was found, in which the chemical engineers figured out how to force nitrogen and hydrogen to react under the extreme conditions such as high pressure, high temperature, and with the ion based catalysis. And the result was one thing most important, ammonia, the foundation stone of the modern fertilizers. Once the nitrogen in that form, plants can absorb it and grow rapidly. A single process massively increased crop yield worldwide. It estimates that roughly half the global population, depending on the food grown, is done using synthetic nitrogen fertilizers. But as always, there is a catch. Producing ammonia consuming high amount of energy and especially hydrogen, which is in the most today cases comes from the natural gas. That makes ammonia production responsible for 1 to 2% of global emissions. From a perspective of the chemical engineer, this is a classic trade-off once again. The reaction kinetics versus thermodynamics. The food security serves the I can say reaction kinetics, but the energy and the climate impacts are with the thermodynamics. So it gets rather food security versus energy. And this is why the companies like Yara are investing in the green ammonia using hydrogen made from the water and the renewable energy instead of the fossil fuels. So next time you have a meal, remember behind your food is a reactor, catalyst, and a reaction strong enough to reshape the civilization. For more chemical engineering and tech facts, it's very simple. We guys already